Hello, this is Mr. Best. Welcome to Chapter 6, Homework Questions 61 to 66. Question 61, solve each equation below and check your solution. So we're back to solving equations with one variable. Let's go ahead and start with problem A. We have 6, and then we're going to distribute. This is like a negative 1 right here, and we have to distribute the negative inside the parentheses. So 6 minus 3 minus x equals 10. Now we can combine our like terms. Subtract 3 to the other side. Negative x, don't forget the negative, is equal to 7. Divide by negative 1, x is equal to negative 7. Also remember that there's not one way to do this. There are other ways that you possibly could approach this problem. Maybe subtracting the 6 first, adding the x to the other side. So just remember that there are other ways of solving. It does want us to check our solution, so we can take the negative 7 and plug it back in to the original equation for x. Now I'm not going to distribute the negative. I'm going to take 3 minus 7 and do order of operations. And then 6 minus a negative 4 is 10, so 10 is equal to 10. All right, question B. We will distribute the 100. So that's 100x plus 300 is equal to 200. I can subtract the 300 from both sides. That leaves 100x is equal to negative 100. Divide by 100. X is equal to negative 1. We also could have divided by 100 in the very beginning without distributing it. So that's once again a different way that we could have approached that problem. Here is the check. And there you go. So 200 is equal to 200. It works out. Question C. We have 1/3 x plus 4 equals x minus 2. Now, in some cases, students or anybody really likes to get rid of the fractions, and you could do that by multiplying by the common denominator of 3. That's a possibility. I'm going to go ahead and leave it in this problem and then maybe address it on question D. So I am going to subtract the 1/3 x from the 1x. That leaves us with 4 equals, this is 1 minus 1/3, that's 2/3, x minus 2. Go ahead and add the 2 to the other side, so 6 is equal to 2/3 x. We can multiply both sides by 3. That's 18 is equal to 2x. And then divide by 2, and x is equal to 9. And then once again we will check our solution. And there's the check, and we do get 7 is equal to 7, so it does check correctly. And question D. Now D, we have a fraction equal to another fraction, so there are once again a couple of ways we can approach this problem. Let's go ahead, as I said in question C, let's go ahead and get rid of the fraction by multiplying by the common denominator. So 5 and 45, what's the common multiple of 5 and 45? That would be 45. So I'm going to multiply 45 to both sides. And what you'll notice, instead of taking 45 times 4, the 45 and the 5 have a common factor of 5. Okay, then I'll take 9 times 4 to get 36. So my denominator is now 1. Same thing on the other side, but the 45 completely cancels to give you x plus 2. Subtract 2 from both sides, and we get x equals 34. And we will once again check to make sure that is correct. X equals 34. And there's the check for question D, and we get 0.8 is equal to 0.8, or 4/5 is equal to 4/5, either way. All right, so there are 4 questions on solving where you have different types of each of them. Question 62, write an equation or system of equations to solve. I'm not sure how to pronounce that name. Than bought 11 pieces of fruit and spent $5.60. If apples cost 60 cents each and pears cost 35 cents each, how many of each kind of fruit did he buy? So when we write an equation or a system of equations, we do need to write let statements. So what is it that we don't know? Well, the end of the sentence says how many of each kind of fruit did he buy? So we can create our let statements off of those things that we're not sure of. So we'll let What do we have? Apples and pears. So let A equal the number of apples. And then we can let P equal the number of pears. And since I have two variables, I'm going to write two equations. Let's see, what do we have? So there's 11 pieces of fruit total. So right here in the first part, it does say he bought 11 pieces of fruit. So if we have 11 pieces of fruit, and there's A apples and P pears, then we know that if we add them up, we should get a total of 11 pieces of fruit. And then the next part, it talks about that he spent $5.60, and an apple cost 60 cents and a pear cost 35 cents. So can we write an equation based off of that information? We have an apple costs 60 cents, so 60 cents per apple, so we multiply that. A pear costs 35 cents, so 35 cents times the number of pears should be equal to the total that he paid or spent, which was $5.60. Now, I wrote my second equation using dollars. If you wanted to, you could use cents and rewrite it as 60A plus 35P, but then $5.60 in cents is 560 cents. So these two are the same, one's in dollars and one's in cents. So it doesn't matter which one you use. So since I wrote it as a system of equation, I want to use substitution or elimination to solve this one. I'm going to go ahead and use substitution. I'm going to take this equation here and solve for P by subtracting A. So that'll be negative A plus 11, or 11 minus A, same thing. And I will substitute it into, let's not get ourselves confused here. Didn't mean to do that. I'm going to erase the A part, the red part. So those are the two equations that I'll be using. And I'm going to replace 0.60A plus 0.35 times P, which now is going to be substituted in for the negative A plus 11 is equal to $5.60. So once again, you can see that there's different ways that you can solve this problem. So let's go ahead and finish this one off. This will allow us to solve for the number of apples, and then we'll have to plug in to figure out the number of pears. And that is a 0.35 times a negative A, so I'm going to change that to minus 0.35A plus 3.85 is equal to 5.60. Combine my like terms, 0.25A. I'm going to subtract the $3.85 to the other side. 1.75, and then divide by 0.25, and A will equal 7. So that means I have 7 apples, and since I know there's a total of 11, 7 plus the number of pears is 11, therefore the number of pears is 4. So how many of each kind of fruit did he buy? He bought 7 apples and 4 pears, so make sure you answer that question, not just saying A equals 7 and P equals 4. So make sure, once again, you answer the question. Han bought 7 apples and 4 pears. Question 63. Find the slope of the line through the points. So given the points, this one previously, we graphed the 2 points and found the slope. This one, we're just going to find the slope given the information without graphing. So A does say find the equation of the line, but first thing we need to do is find the slope. So let's do that first. So the slope is the change of y over the change of x. So we're going to subtract our y values and divide it by subtracting our x values. So remember, this is minus a negative 4, so that's a plus. So that's negative 4 divided by 3. So our slope is negative 4/3. On part A, it wants us to find the equation of the line. Well, now that we have the slope, we're going to use the slope negative 4/3. And either one of those points is fine. I'm just going to pick the first one. And we're going to plug that into the equation y equals mx plus b. So negative 8 equals negative 4/3 times 6 plus b. And we're going to solve for b. Remember, this is 6 over 1. So you could do negative 24 divided by 3, which is negative 8. You could cancel the 3 and 6 and get negative 8. but either way, you get negative 8 equals negative 8 plus b. You add 8 to the other side to isolate the b, and we get b is equal to 0, which means it crosses through the origin, and so your y-intercept is 0, 0. So your equation is y equals negative 4/3 x. You can put the plus 0 if you want, but it's not necessary. Either one is fine, though. So that is part A. Part B is the point negative 3, 4 on the line that you found in part A. Well, to see if it's on the line, it should satisfy the equation when you plug it in. So if I plug in 4 for y and negative 3 for x, they should be equivalent. So 4 is equal to, this would be positive 12 over 3, because that's over 1. 12 divided by 3 is 4. So is the point that you found in part A, or is the point negative 3, 4 on the line that you found in part A? Yes, it is. Dorena is confused. She's making an XY table for y equals the absolute value of x plus 1. She's trying to find y when x is negative 3. But she is not sure if she should find the absolute value first or if she should first add 1. Explain to her what she should do first. Justify your reasoning. Now, if you are going to create an XY chart and you're plugging in the number 3. So if we plug it in, it should be y equals the absolute value of negative 3 plus 1. So really the question is, how do I simplify this to solve for y? Because the absolute value is a grouping symbol, you definitely need to do what's inside the absolute value first. So you do need to take the negative 3 plus the 1, then take the absolute value of negative 2, which is 2. So because absolute value is a grouping symbol, you need to simplify inside the absolute value first, then take the absolute value once the inside is simplified. So you need to explain that and justify your reasoning. Question 65. Solve this system of equations. So we did a system of equations earlier, but we created it. This one they're going to give to us, and then they're going to ask us a couple of questions based off that. So let's just go ahead and solve it as it asks, and then we'll answer the question. So this one looks to me like it's set up for substitution. Y is solved for, so I'm going to go ahead and take the second equation and replace the replace the y with 2/3 x minus 4, and solve the equation from there. Now, be careful, there is a negative 3 on the outside of the parenthesis, so include that negative. So negative 3 times 2/3 is negative 2x. Negative 3 times negative 4 is a positive 12. So the x's cancel, and you get 12 is equal to 10. But 12 is not equal to 10, and you are trying to solve for x, so something happened here. Let's go ahead and look at part A, B, and C and see what we can do to address this. A, what does your solution tell you about the relationship between the lines? Well, because the x's cancel out, we do know this is a special case. And since there are no solutions, the only way you can have two lines that do not intersect is if they are parallel. So what does the solution tell you about the relationship of the lines? We know that the lines are parallel. Part B, solve the second equation for y. Okay, so we're going to take the second equation and solve it for y. Now, as we're doing this, think about if the lines are parallel, what's that going to tell you about the second equation once we get it into slope-intercept form? So we'll subtract the 2x. That's negative 3y equals negative 2x plus 10. And then we can divide everything by negative 3. So we get y is equal to negative divided by a negative is a positive, and then negative 10/3 at the end. So that's part B. It doesn't tell us to do anything, but then on part C, it says, does the slope of each line confirm your statement in part A? So that looks like the slope in this one is 2/3. Let's go back up to this one, and then your slope in this one is 2/3. So does the slope of the line confirm your statement in part A? I would say yes, but we also have to be careful. Just because the slopes are the same, we also have to understand that if there is no solution, that the y-intercepts also have to be different. So on this one, it's 0, negative 4, and then on this one down here, it's 0, negative 10/3. So yes, they are also different, which is important to confirm that our statement in part A, where there is no solution, if we are actually solving it, no solution, then that is important to look at as well. So I included both in my explanation. Yes, the slopes are the same and the y-intercepts are different. Question 66. Figure 3 of a tile pattern is shown at the right. If the tile pattern grows linearly, and figure 7 has 13 tiles, then find the equation for the pattern. So we know it's linear, which is important. I'm going to go ahead and set up a table so we can kind of see what we're looking at. Remember, x represents the figure number, so this is the figure number, and this is the number of tiles. So it tells us right here, figure 3, I don't have to write it down there, but figure 3 has how many tiles? 1, 2, 3, 4, 5. So it has 5 tiles, and then it goes on to tell you figure 7 has 13. So if it's linear, then we should be able to find the growth rate by finding the slope, and then we can also find the initial figure 0, so we know how to write the equation for the pattern. So let's go ahead and do that. Let's find the slope, or the growth rate. We're going to take the change of y, 13 minus 5, over the change of x, 7 minus 3. So that's 8 over 4, which equals 2. So we know the growth rate is 2, so the number of tiles are growing by 2. We could work backwards and go 2, 1, and 0 on our figure number. I'm going to go ahead and just use the information that is given to find the b value. So I'll use the first point and say 5 is equal to 2, which is my growth rate. X is 3 plus b, so 5 is equal to 6 plus b. Subtract 6, b is equal to negative 1. So having a figure 0 with negative 1 tiles doesn't necessarily make sense, but we can still write the equation for the pattern to find figure 10, 100, whatever it might be. So we're going to say y is equal to my growth rate, which is 2 times x, so that's my slope or my growth rate, and then minus 1 would be figure 0.